Hi, welcome back to PR Tech Talk. Today I'm going to continue using the STM32C0 microcontroller. And I'm going to take a look at the I2C interface and to see how that works and how to get that be running on the microcontroller. And to demonstrate it, I will use a small OLED display, graphical OLED display based on the popular STM32C031 driver chip. So if you find that interesting, so please tag along. We have started the STM32 cube and we can start a new STM32 project. Here I can ask for the board. I know which board I have, so it's the Nucleo. It's this board. Here we can see a lot of information on it, and if we go on the docs and resources and we go under user manuals, I think it is, and then we have the board information. We get this user manual, and we will be using this later to actually identify where the pins are on the I2C, and if there is a picture down here somewhere, yeah. So this is a very good picture to have to see where all the pins are available on the board. So we can save that for later. So we give it a name. Hit finish. Here we start with, let's make sure that the serial wire is enabled. And we also would like to have a connectivity. So the I2C is there. So we have it on PB8 and PB9, and that is crucial to remember where the PB8 and the PB9 is. So you have it on the Arduino headers here, and you have it, and these are female and these are male pins. So depending on what you would like to have. So there you have the PB9 and there you have the PB8. And also you need some 3.3 volts for my display, so that is on pin 16 and ground is either on 22 or 20. Just so we remember how to connect it later on. Like so, and we can also do like this on the parameter settings that we can enable the fast mode, so it goes up to 400 kHz. We can Control S for save. Do you want to generate the code? Yes, please. And you can also change the perspective. Great. So now we can just see if we can build a project. It worked fine, but there won't happen anything because we haven't entered any information on it. But we can, just for curiosity, see how much memory we have used. In this small 32C0, we have 32 kilobyte of flash, and we have used 8.11 kilobyte of the flash so far. And after we added the graphical library, we will see how much we will have used by then. So to enable this display, we need some drivers, and these are available on GitHub. So you can go under GitHub, and there are many versions of this STM32C031, but I choose this one. So I just hit code there and downloaded the software to a zip file. And when I have done that, unzips in this file structure, and there is a folder called STM32C031 Nucleo. If we open that folder, we see that there are a couple of files, and we can do actually like this. We can copy all of them, and we can move to where we have placed our project. And so this is the project that we just created in STM32Cube. So under drivers, we can make a new folder. Give it a name. And in that folder, we can paste all the files. Then we go back to the project again, and we can refresh the content with F5. So under the drivers, we should now see that the folder that we created, but we still need to tell a cube that we actually added a folder there. So we right click on the project name, on the project header, and we go under properties. And then we go under C++ general, path and symbols. And there we have path to the various libraries and directories it has connection to. And we will add to this where we added this one, and we put it under drivers, and we put it there, OLED. Okay, so now it's here, it's OLED. So now that OLED is in the program, now we need to make some changes also. We need to include this H file, and private includes, so we do that. Like so. And we also need to make some changes in the driver. So we go into the driver OLED and see that there is a file called STM32C031 conf template. We open that one. So the STM32C031-conf_template.h. Now it says here, choose microcontroller family, and we have an STM32C0. So we look here and there is no C0. So what is happening then? Well, we do like this, we create it. And that's not that hard as it sounds. We make a new define, an STM32C0, and we decomment the rest of them. And here we also need to see, I'm using the I2C, so that is the one. If you want to use the SPI, you need to comment that one and decomment this one instead. But I2C is the one I have today. And it also says what the I2C port we have. And it says also with address, and this is not the one that I'm using. And mine is OX78, so it need to know what address to look for. And then we can go down, if you are low on memory, you can exclude those fonts that you don't use, but we don't do that in this case. We need to define, we not need to, but I would like to do it anyhow. So I define the width of the display, which is, and the height of the display. So it's 128 by 64. And then we hit save. Now we need to rename this file because it can't be named template. So we right click on it and we hit rename, and we just remove the underscore template, making sure that the .h is still there. Great, so now we have renamed the file, and when we try to build the project, we get a lot of errors and a couple of warnings. And we get exclamation marks here on the C and the H file. What is wrong with code? So let's go down here. It says there was some problems. Great, please modify STM32C031 if you know what you're doing. And of course we know what we are doing. So we do like this. We copy these two lines. And we write C0. And we need to change this one also. And we try to build it again. Voila! So now we're done. 0 errors, 0 warnings, and now we have also made sure that the file, the library also includes the C0. So we can close the H file and go back to the C file. So the project and the libraries are prepared, and now we need to make some code to be able to initialize the display and to write something on it. So we go to the main C file where we already have included the STM32C031H file in the user code begin includes. And then we're going down to, in this case, we're going to write a string to the display. So we're going down to the main, and here we will have, we put a string like this, text OLED with the content PR Tech Talk. We can write it with hello OLED. That is what we need there, and then after this initializations, we have initialized sorry, the I2C and the UART. Under here we can have our own init code. So we start with STM32C031 init, and then we can write STM32C031 set cursor, just so it has somewhere to start. So we write 0.0. And then we give it an background color. I'm not sure if that is absolutely needed, but so we put fill. And what color do I want? I want to have black. This is a monochrome display, so I have white and black to choose from. And then we're going to write a string. Clump fingers. Write string. And the first it wants to have is the string, and there we have the OLED text. And the font, we can go with 7:10, or we can use 6:8, or we can make a different font, but we will go with 7:10. And then again color. And then since we have a black background, I suggest that we go with a white foreground. It's much easier to see. So that we have done, and now we need to actually do like this. We need to send that information to the display. And there is a command for that as well, update screen. And it doesn't take any parameters. So what we do here in the beginning, we create what we would like to see on the screen, but we do it in RAM. And with this one, we send that RAM information out to the display to show it. Now let's see how many errors we did. Great, so 0 errors, 0 warnings, looks good. Now we need to put that code down into the microcontroller. So we get on debug configurations. And I have already a debug configuration here. And we can see that it indicates that it finds our JTAG. So everything sounds fine. And we can switch to the other perspective as well. Here we see the board, the STM32C0, with this small OLED display with 128 by 64 pixels communicating over I2C. So I have 4 pins connected to the STM32C0 board, and that is VC 3.3 volt and ground, and data and clock. Serial data and serial clock. That's it, and there is a small graphic running on it now showing my logo. PR Tech Talk. It's very small, but it says PR Tech Talk there. And we run the code. And it says hello OLED. So the project worked fine. We can stop the project and go back to our main C file. And here we can then just make sure that there is actually something happening there. So we can see PR Tech Talk. We compile it, we debug it, and I'm changing to the bigger display. See if I can get out of the glare so we actually can see what's happening. So I run, so it says PR Tech Talk. So it worked fine. Happy to do that. So we actually adopted the driver library for the OLED also to be incorporated into the STM32C0. And if we take a look down here, we can also see now that we have used what memory footprint we have with this small application in this. So the 32 kilobyte we have used 13.19. So we have used like 40%. So we have 60% still left for other stuff. So you can do quite a lot with this small microcontroller. Okay, so the demo worked fine. We used the STM32C0 and took a look at the I2C module, and to visualize that I put a small OLED display on it and took a library file, included that into the project and adopted it to the STM32C0 since it was not natively included into that driver, but it wasn't that difficult. So if you liked the video, please give it a thumbs up, and that will help a lot if you give it a thumbs up, because then the YouTube algorithm will share it with more and it doesn't cost you anything. So I really appreciate it. If you have any comments, please leave it in the comment field below, and if you're not a subscriber, please consider to do so. So until the next time I'll see you, stay safe. Bye.